Hello everyone, welcome to my YouTube channel Precision Manufacturing System. I'm back with another video in series of SPH simulation. Of course, simulation of SPH method by Abaqus. And in this tutorial, in this video, I'm going to explain how the SPH method simulate bird striking and aircraft wings. And please, before starting the tutorial, I would really grateful to subscribe to my YouTube channel and hit the like button and stick around until end of this video, because in this video I'm going to show you a step by step of this simulation, and you after watching this simulation you would be able to run your simulation by yourself. Okay, let's start. And for this simulation we have two different parts. First, let's assume this is our bird, and this is the deformable model, of course a solid deformable model, and the radius and dimension is like this. The radius of this circle is 3 millimeter, and it has a 8 millimeter depth. And also for wings, the wing is considered as a shell and deformable also, and the geometry of the wings is like this one, or whatever you like, you can draw it by yourself. Okay, and after so both of these part are considered as a deformable. And then for property, we have two different material. For wings we consider and defined AL sheet, and for bird we considered water material also. And as you can see, the for aluminium we defined elastoplastic material behavior, density, and elastic Young modulus and Poisson ratio, and also plastic behavior. We defined all these number, and all this number is based on megapascal. And also for Brid we have to define density and dynamic viscosity, and also we need to define equation of a state. And equation of a state, you can define equation of a state from this menu. And for type of the equation of state, you have to select USUP, and you have to set this number for C0, and S and gamma should be defined as 0. So after defining these material, we can keep going our simulation. And our section, as I already mentioned, for bird we defined solid material, and also for wing we defined a shell, and the thickness of the wing is 1 millimeter. And okay, we assign the material to each of them, and then to assembly by you can import your part by clicking on create instance, and by choosing each of them and clicking on apply, you can import your model and arrange your model whatever you wish or wherever you want. Okay, and then we have to define our step, and for this simulation we have to define dynamic explicit, and for time period we set 0.01 second, and we need to define mass scale 1000 mass scale is okay for this simulation. If you need a special field output, or you can define from here, but since this is a just tutorial and tutorial video, I'm gonna show you just the procedure of the SPH simulation. So here we don't define anything, and then in interaction we need to define interaction between the bird and wings. So for interaction we need to define contact and tangential behavior, frictionless, but we define normal behavior and hard contact, because there are hard contact and between bird and wings. And then since we will convert this solid part to a particle, we cannot define surface by surface, and for that's why we need to define general contact for our model, between our model, and here we define general contact and all with itself for our model. Okay, that's it from our interaction, and as you can see there is a little gap between wings and bird. Okay, and now we have to first define our mesh, and then we can define our boundary conditions, because the boundary condition of bird should be defined on node. So first we need to define boundary mesh for our model. Okay, this is free quad is okay, and explicit shell okay, and then for bird we define 0.5 okay. The most important section for meshing and converting of SPH simulation is in this section is here. We have to select explicit linear, and here we have to click on this option. The generally and basically the in this option is like this one, conversion to particle is set on use default, but you have to put it and select yes, so that in visualization module, after finishing your simulation in visualization module, you will see particle instead of a solid part, and then you have to set 0 for threshold, and just this one, and click OK, and then this is our solid part of bird, and then we need create a node set for defining boundary condition. Okay, and then in load we need to define boundary condition for edge of the wing. Okay, and then for Brid we need to define initial velocity, and for defining initial velocity you should click on predefine, and here you should select mechanical and velocity, and then from here choose node and continue, and then it should have velocity in x direction. So put write 8,000 for in x direction, and for other direction we put 0. Okay, just this, and now our simulation is done. And since I'm using a student version of Abaqus, I cannot run this simulation, but you should create a job, and if you have a strong workstation, you can also set a multiprocessor for your simulation. Otherwise you can run without any processor and run your simulation by your computer. But I have run this simulation before, and I have the result, and I will show you the result of this simulation, and so you can watch and see the result of this simulation. As you can see, the particle, the solid model converts to a particle. Okay, thank you so much for being until end of this video with me, and if this video is helpful for you, please hit the like button and share with your friends. And also I'm really grateful if you could subscribe to my YouTube channel, and because this your subscription could be motivation for me to create such this video. Thank you so much. I will back with another video so soon.